Well, hello, welcome to this part. So on the last video, we talked about how to calculate an empirical formula, what it was, how to calculate it. And so on this one, your success criteria is going to be that you can calculate the molecular formula from an empirical formula. So once we have the empirical formula, how do I then find the molecular formula if they're not the same thing? So let's just go on. So remember the definition of an empirical formula. Empirical formula contains the smallest possible whole number that describe the atomic ratio. So it's always the smallest. Again, it is like your fraction reduced in simplest form. Okay? Where your molecular formula is the actual formula, and it may not be the simplest. Okay? It might be, and it might not be. And I'll give you some examples of when they're the same and when they're not in class. We'll go over that. So an empirical formula, again, may or may not be the correct molecular formula. The relationship between the empirical formula and the molecular formula can be written as follows. And so it is X times the empirical formula. What does that mean? So let me use an example. If I had the fraction 1/2 and I said, okay, you have the fraction 1/2, give me another fraction that is the same as 1/2. And so you might say, well, 3/6. Okay. Well, how did you get 3/6? Well, you multiplied both the 1 and the 2 by 3. So that's exactly what we're talking about here. That X in this case, that factor, is the 3 that we used with our fraction. Okay. The only thing is you're going to have to try to figure out what that X value is. Okay. So how do we calculate it? So a couple other things to go along with that. When we talk about the formula masses, okay, they have about the same relationship. So let's say the formula mass for water is 18, okay? If you had another molecular formula that might be, instead of H2O, was what number did I want? H6O3, then its mass would be 3 times as much since I multiplied it by 3. Does that make sense? So if you take, again, your factor, that 3 times your empirical formula's mass, you get the molecular formula's mass. Okay? So hopefully that makes sense. Again, we're going to do some examples. Okay? So to determine the molecular formula of a compound, again, you've got to know the formula mass. So you're going to have to be given that formula mass value. So you're going to take the empirical formula and you're going to find its mass, okay? And then you're going to divide it into the mass of your molecular formula and find out how many times it is. And that's your scale factor of X, okay? Again, this just says that a compound's molecular formula mass is numerically equal to its molar mass. So the compound's molecular formula can also be found given the compound's empirical formula and the molecular mass. Please do not write that down, okay? So pick and choose what you write, guys. Not everything that I put on the slides needs to be written down. In this case, all I would do is what's in the yellow, okay? So let me give you an example. This one is determine the molecular formula of a compound that has an empirical formula that is CH, so C1H1, but it has a formula mass of 78.110. Okay, so if you on your paper real quick would note that you have an empirical formula of CH, and that you have a molecular or a formula mass. Let's do that. Let's formula mass. You could call it molecular mass, but formula mass at this point, because we don't know, of 78.110 AMU. So we're going to write just that piece down. Okay, so on this example, we've got it written down. Our empirical formula is CH. Our formula mass is 78.110 AMUs. So what we're going to do then is we are going to find the mass of CH. Okay, so that has one carbon and one hydrogen. So we're going to look it up. Carbon is 12.01, okay, 011, and hydrogen is 1.0, whoops, 1.008. So we have one of each. Again, if we had more, you'd need to write it out like what we did before. Let's add that up. So we got 91013. So I know the mass of CH is 13.1019, which means that that formula mass is is not the empirical mass. Okay, so we're going to now decide what is our factor. Well, how many times will that 13.019 go into the 78? So let's get our calculators out and let's calculate that. Now, I hope you're pausing also and calculating it. Now, I did it and I got that it was 5.999. Now, again, this is kind of where we're going to do an estimation because roughly that's 6, right? And hopefully you realize that because we're rounding our masses, that those might not always be perfect, but our scale factor, our X value, is 6. So what that means is I am going to take, to get my molecular formula then, okay, I'm going to take my subscripts, in this case it's just 1 and 1, and I'm going to multiply them by 6. So this is C6H6 is my molecular formula. Okay. So that is what I'm looking for. So again, they're always going to give you, well, they're not always, but once you have your empirical formula, they will always give you the formula mass. Okay. So you're going to find the mass of your empirical formula. If it is the same as the formula mass, then you don't do anything else. Empirical and molecular are the same. But if they're not the same, then you need to do a division and see how many times it'll go in, and that'll give you your scale factor. And then you just multiply your atoms, number of atoms, your subscripts by that scale factor. That's all you got to do. So the difficulty in this problem is when they put the above problem with this problem. They add it and make it all one problem. Okay, but you can handle it. I know you can.